This is Software Engineering Radio, the podcast for professional developers, on the web at se-radio.net. SE Radio brings you relevant and detailed discussions of software engineering topics at least once a month. SE Radio is brought to you by IEEE Software Magazine, online at computer.org/software.
This is Robert Blumen for Software Engineering Radio. I'm joined by Grant Ingersoll. Grant is the chief scientist at Lucid Imagination, a committer on the Apache Solar and Lucene projects, the author of the book Taming Text, and the founder of the Apache Mahout project, which we will be discussing today. Grant, welcome back to Software Engineering Radio.
Thank you. Glad to be here again.
I say welcome back because Grant was our guest on a previous episode 187 about search and the Solar search engine. Today, Grant, you and I will be discussing Apache Mahout and machine learning. First, can you tell us what is machine learning?
Sure. Yeah. No. It's a great question because I think a lot of people end up when they hear the phrase machine learning, they often think about computers taking over the world and things like that. But really, what machine learning is trying to do is look at previous examples or essentially a historical view of your data, and then try to make predictions about what that data is doing, typically using some sort of statistical analysis of that data. So the common things to think about with machine learning is if you have, say, you're taking in all of the world's news and you want to be able to classify it into buckets that says, this article is about sports or this article is about politics. That's a classic example of machine learning, or that's a kind of problem that can be solved with machine learning. So you're often looking at ways to organize your data into something that is more easily consumable by people.
Grant, what are some other problem cases that machine learning addresses successfully?
Sure. Yeah, there's a pretty wide variety as it turns out. So the general scope of classification, there's a number of use cases. It's commonly used in fraud analytics, detecting whether, for instance, somebody is committing credit card fraud. It's used in analysis of healthcare records to try to identify patients who are at risk. So if, for instance, you've ever had an EKG or you've gone for some expensive tests, there may very well be machine learning being applied there to help doctors narrow down. You've also probably seen machine learning if you've ever done, for instance, online dating or something like that, or if you've gone to Amazon and you've bought something and then it's recommending other products to you. So anytime you have this kind of question of people who bought this also bought that, that's a classic machine learning example. I've seen it used pretty successfully in utility companies, for instance, where they take all of their input from their smart grid, as part of the power supply, and essentially they use tools like clustering to try to detect anomalies in the system. So if a set of machines or capabilities on the smart grid, they produce kind of what you would call a normal signal, right? By the fact that they're operating correctly, and so all of those signals will cluster together, and then any outlier may very well be representative of something that is wrong in that system. So there's a wide variety of use cases. Also, anybody who's familiar with what IBM Watson did on the Jeopardy program, a whole lot of machine learning goes into that in terms of taking the text, taking the questions, taking the answers that they have, and parsing that language, trying to figure out what exactly the answer or the question is, and then providing back a suitable response. So all of those are, I think, pretty good examples of using machine learning to solve highly complex problems.
Maybe I'm taking the expression machine learning too literally, but does it mean that the machine learns, or is it us who learn from the machine?
Yeah, that's a good question. I mean, I think all the obviously the machine is just doing what you tell it to do, right? So what is learning in the sense is that it's looking at past examples and then using that to try to figure out how to predict some future event or some current event, right? So if 10 times out of 10, when a certain article comes in and mentions, I don't know, Alex Rodriguez and the New York Yankees, some human has said this article is about baseball, the machine can learn that pattern. And obviously what you're typically talking about is much more complex problems where there's a lot of different variables that come into play. We as humans aren't so great at being able to deal with a lot of variables at once, but the computer can often do that by looking at a lot of examples and trying to figure out what the probabilities are of things occurring the way they occur, and then make guesses based on those probabilities going forward. So it's not, I guess it also depends on what your definition of learning is too.
Sure. Can you talk about the distinction between supervised and unsupervised machine learning?
Sure. So supervised, as it kind of the name implies, is there's some human in the loop, if you will, in the sense that what you typically do is you take some amount of data that you've collected over time and you split it up into usually two groups, but it may be more than two groups. And then you pick one group out of that and you have people actually go through and apply labels to that content. So for instance, using the news example again, you maybe would have 100 articles or 1,000 articles, and you would have some people would go through and actually apply labels based on their judgment, right? So now you have the answer to those 1,000 articles, right? And then you would take and feed that into the training part of the algorithm, and it would essentially learn what words are associated with which topics, and it would output a model. You then would take that model and hook it into your main program such that anytime any new article comes in, you would simply be asking the model, what label should I apply to this? Unsupervised, as the name also implies, of course, is there's no human involved. So what we're trying to do is use pure statistical techniques or algorithmic approaches to try to figure out how to group or organize content. So in many cases, clustering is often an example of unsupervised learning because you're just simply looking at what is similar between these two documents or these two items, whereas the classification of the news article stuff is often done as a supervised task because you have some human who's doing the annotations or the labels ahead of time.
Okay. Is machine learning the same as data mining, or is that something different?
I don't know. A formal definition-wise, I think they're pretty similar. Data mining probably is inclusive of machine learning. They're all trying to get at what are the patterns and formulas or whatever that describe this data in appropriate ways, all with the goal of surfacing relevant information up and out to users such that they can make better decisions on it. I don't know specifically the formal definitions. Somebody else probably could jump in on those.
Okay.
And of course, they've changed over the years as well. But I would say data mining could also include rule-based systems or other kinds of systems that aren't necessarily a machine learning approach.
Okay. Would it be fair to say that machine learning is becoming an increasingly significant part of modern applications?
Yeah, I think that's probably an understatement, especially when you talk about on the web or any place that you're dealing with large volumes of data, i.e. the big data movement. I think what's powering that is machine learning. So if you go to the Googles and the Facebooks, or basically anytime you're on on the web these days, chances are there's somebody who's using machine learning techniques to try to get a better understanding of what you're doing. Ad targeting or advertising on the web is another classic example of machine learning. Where they're simply asking the question, should I show this ad to this person or not? So based on their profile, they're asking the question of their models, whether this is a relevant ad or not. And chances are they're doing that using machine learning approaches.
Is this growth then, is it primarily because we have a lot more data, or because we have enough capacity to process the data now, or because these algorithms have been discovered and tuned, or all of the above?
Yeah, I think it's all of the above. I mean, I think, as I mentioned earlier, we as humans aren't necessarily capable of processing that much data. And so you need, and at the same time, computers are really good at doing, these kind of statistical pattern recognition kind of things. And so the combination of the two things is, I think, what helps keep us afloat in many regards. And it's also, as Google and Facebook and the like have proven, it's often a differentiator in terms of business capabilities as well. Because if you can have a better understanding of what your users are doing with your content, then you can better target or refine and learn from what they're doing to make it better in the future, which presumably attracts more users, et cetera.
Are businesses then usually able to quantify the impact or the return on investment of implementing machine learning, or implementing a particular machine learning feature?
Yeah, I think in many cases they are. The fraud analytics, that's been using machine learning techniques for quite a number of years, and I think generally speaking they do pretty well there. Spam, finding and identifying spam is another classic machine learning approach or technique, a classification problem. I think most spam detectors these days do a pretty good job, at least in my view. When I look in my inbox anyways, I have that sense. Granted, that in those kinds of situations where you have an adversary, there always seems to be a back and forth as each side adjusts their algorithms. So this stuff typically is not a do it once, deploy it, and you're done kind of situation. You have to reevaluate your models on a periodic basis and make sure you're capturing feedback from your users and your system so that you can feed that back in.
That point you've just raised about feedback, that's something I find very interesting, and I'm going to ask you some more about that when we get into the particulars of recommendations and clustering. Another general machine learning question I have is, what kind of sizes of data sets are we talking about here, and how long does it take to run
Sure.
a machine learning algorithm? Are we talking millions, 100 millions?
I mean, it depends on the situation and the amount of data you have. I mean, some algorithms are only sequential and will only run on, for instance, one machine. And so what's often happens there is if you have a lot of data, you're going to downsample or take a sample of that data and then apply your techniques to it. And it tends to be a little bit more hand tuning around it. But certainly, when you're talking internet scale, you can have millions and millions or hundreds of millions or billions of events. And there, obviously there's no, you need a parallel or distributed approach that's going to help you do this. And so what you've seen in the past few years around the big data movement, of course, is more and more algorithms that are designed to take advantage of distributed computation models, right? And so, for instance, I was just in Japan a few weeks ago, and I was talking to one of the large online mobile social gaming sites there, and they have 400 million users, and they're doing, I don't know how many games they have, but if you start to think about the size of that matrix, 400 million users times however many things they're tracking, that's quite a large matrix, and so you need distributed techniques to be able to deal with that.
Can you tell us anything about what this platform was doing with machine learning?
So there are a variety of things. One was being able to understand and recommend games. So if you bought a particular game, then being able to recommend other games that other users who are similar to you may have bought or used. That's probably a pretty classic online example. Um, but they also some of these systems also can factor in the way players play in the game to then tune what happens in the game based on these kind of statistical patterns, right? So if you were doing really well, and some of this is artificial intelligence, obviously as well, but being able to detect how fast you're going through a game, and then you can make it easier or harder. I think those are some options as well.
Now, are these algorithms typically then run on a large batch of data, or once it's been trained, can you then take classification as an example, classify each new event as it hits the system within a interactive type of latency?
Yeah, I mean, so again, some of it's going to depend on the algorithms. So, for instance, Mahout has some, and we'll get into Mahout, I'm sure, but has some algorithms that are what we call online learners. They can be updated interactively, and others are more batch oriented. So, it really depends on the type of algorithm. And then you want to make appropriate choices around your needs. Often it's the case that the online or the batch ones, you can obviously deal with a lot more data because you can distribute that work, and it may take you an hour or two or even longer to build the model, but once you have the model, it's a very rich model. Whereas the online ones, you're making some trade-offs there about how much data you can look at in order to be able to make decisions much more rapidly and update the decision incrementally as you go, right?
If I buy a book at online bookseller about a subject I've never bought books before, they might be able to update my recommendations of books I might like immediately based on now they've discovered that I'm interested in this new topic.
Yeah, that's a classic example. I mean, I don't know if, I'm not that familiar with some of the inner workings of those companies at that level as to what they do. I'm sure they have a combination of machine learning plus rule-based systems, but yeah, I mean, you want to be able to instantly look at what happened, what books you've bought, compare that with books that other users have bought, and then be able to essentially kind of put you in a neighborhood or put you around people who are like you that way, and then make recommendations based on things that you have not bought and that they think you might be able to like. And usually you can update that pretty quickly, but oftentimes it's maybe within a day or so, right? Because it's not always that urgent, and oftentimes if you've been a customer there long enough, it's not necessarily going to change drastically in a very short
period. Or they know that I shop on that site once a week, so if they don't get me this time, they'll get me next time.
Yep, that's exactly right.
Okay. Grant, now I'd like to shift gears into the Mahout project. What is the Mahout project?
Sure. So Mahout is an Apache Software Foundation project, just like what we mentioned earlier with Lucene and Solar. That's with the simple goal of building, I guess maybe not simple goal, but with the goal of building scalable machine learning algorithms or a scalable machine learning library. So what we've done is gotten together a bunch of people who have been working on machine learning in this space and try to build out a set of commonly used, proven algorithms and make sure that they can scale. In many cases, this means we try to use tools like Hadoop and MapReduce type applications, but in other cases, for some algorithms that aren't easily made parallel, we just simply try to make sure we have very efficient implementations of those algorithms. And then, we want to build community around that, so there's a large number of practitioners who are using and contributing to the project. And, of course, we want this to be Apache licensed, and so it's free and open source and all of those good things.
Is there a story behind how you founded the project?
Yeah, I guess so. Well, it kind of came out of Lucene in the sense that I had emailed on the Lucene list. I don't even remember when. This was a few years back. That, kind of looking at how search is evolving and how machine learning is often used in helping solve search problems or search-related problems or text-related problems, and basically saying, I could see the Lucene project evolving to have those kinds of things in it too. Fast forward maybe a year, and this woman, Isabel Drost from Germany, emails me out of the blue and says, "Hey, are you still interested in a machine learning project at Apache?" And she was also a Lucene user, and so we started emailing on it, and we each reached out to a few other people who we knew were interested in machine learning at the time, and then we got together and started trying to figure out how we could create a machine learning project that differentiated itself from some of the other open source machine learning libraries out there, and Mahout is what we came up with. We had originally thought we would, this is around when MapReduce and Hadoop were just starting to take off. We had originally thought we would solely focus on implementing on Hadoop, but that has evolved over time to the point where we're much more pragmatic about wanting to just make sure we're delivering scalable machine learning libraries using Hadoop where appropriate, but using other techniques as well, because those happen to solve the problem better or in a different way.
Then is it accurate to say that Mahout is a toolbox of machine learning algorithms that can be mixed and matched according to the problem at hand?
Yeah, that's exactly it. And I would say, we tend to focus Mahout on, or Mahout. Some people some people call it Mahout. Some say Mahout. I tend to say Mahout out of habit. I tend to say Mahout focuses on what we call the 3 C's: classification, clustering, and collaborative filtering. But we also have, some utilities and things that help support those, as well as we have a good number of math libraries and tools for efficiently with large collections of doubles and floats and stuff like that. So kind of all the underpinnings of these machine learning algorithms are either matrix algebra, linear algebra, or statistical analysis, and so you need a good set of libraries around those. But primarily focused around those 3 C's, if you will. What we try to do is pick algorithms that we think are proven out and are able to scale, as opposed to necessarily implementing all of the, every last latest and greatest bleeding edge algorithm that maybe hasn't been proven out in industry yet.
Grant, you talked about scalable algorithms. Can you typically target the same algorithm to Hadoop or single node based on the size of the data set? Or are there Hadoop algorithms and single node algorithms that are different algorithms?
Some of them are different, some are the same. Most of our Hadoop, Hadoop, you can run Hadoop on one node and it'll work just fine. It'll take longer than the same algorithm coded up to run on just one node. But obviously the benefit is that you can scale it out. You can just simply add nodes, and Hadoop should be able to scale with that. So most of our Hadoop implementations also have a sequential version that we often code up as a reference implementation, but they're also perfectly usable. And then other algorithms simply have no Hadoop equivalent, and those those typically just run on a single machine. But they often, we try to make them as fast as possible. Or you can distribute them in other ways. So for instance, the classic example for that in Mahout is what's called stochastic gradient descent. Kind of a mouthful, but it's a form of logistic regression, i.e. you're trying to essentially draw a line between objects that you're measuring. That one's completely sequential in Mahout, but it's also very, very fast, and it's also something where you can deploy the models in a kind of a replicated environment. So you can serve up a very large number of classification results all at once, just by kind of creating a multi-threaded approach or a replicated approach.
What are some of the flagship users of Mahout project that you're aware of, and what are they doing with it?
Yeah, it's well, one of the things with the open source is you don't always know who is using it. I continuously meet people who are doing interesting things. Of the ones that are public, I know they've declared what they're doing with it, but they don't always declare, what exactly. They'll say we're using it, but they don't always say in what way. I know, for instance, Twitter uses it. I'm not sure what parts of it they're using. I know Foursquare uses the recommendations library. I know I'm pretty sure Amazon's IMDb or some part of their movie recommendations is powered by Mahout. Many people are using the recommendation capability. That's been around the longest. Probably has the most number of features and is what often attracts people to Mahout. That being said, I know some advertising companies, for instance, who are using Mahout at very large scales to do classification, to basically answer that question: should I show this ad to this user or not? I've met a number of people in government who are using it to be able to classify and organize content. In fact, I met somebody the other day who was using it for doing classification on a tunnel maintenance vehicle or something like that. So it really is quite a wide variety of cases. I know personally at LucidWorks, we use it in a number of ways in our big data product. We provide clustering out of the box. We provide classification as a service. We also do things like try to identify what we call statistically interesting phrases. We also do use it to detect duplicate documents. So, there's quite a large variety of usages.
You mentioned a few minutes ago you were trying to create a project that was differentiated from the competitive or from the competition. How is Mahout differentiated from some other machine learning packages out there?
Yeah, that's a great question. I mean, of course, some of this has changed over time as the big data movement has come on. But I think there was a few things. One, many open source machine learning algorithms at the time were either very research oriented, or we didn't particularly care for the open source license that they had because maybe our work restricted us from using that particular license. So the Apache license is very permissive in terms of usages, and so being people who had already worked at Apache, that was very comfortable to us. Many of them at the time did not have good documentation around it, and then also many of them did not scale. And so that doesn't mean there's not scaling isn't necessarily. Doesn't mean it's not useful, but in our particular case, the people who founded this and worked on the project, we really wanted to make sure these algorithms are scalable. Since then, this was 4 or 5 years ago. I guess it's been already. The space has evolved quite a bit, and I think many of those cases still stand for us, but it also is evolving as well.
You talked about the origin of the project as, in your mind at the time, extended feature set on Lucene and Solar. Could you say more about what is the relationship between machine learning and search?
Yeah, that's a great question. I mean, I wouldn't necessarily categorize it as an extension of those, although there certainly are places you can use machine learning and search. A common use case that I have is as content's coming in, I want to classify that content. I want to put labels on it, right? And then I'll feed that into, as those documents get indexed into my search engine, I will then, obviously index those new labels too. And so then in my search user interface, as user search, I may show facets that show what those labels are, because essentially what you're helping the user do is get a better sense of what this content is about, right? And so, if you can show up labels that say, here's 100 results, 50 of them are about sports, 30 are about politics, 10 are about whatever, and on until I've filled it out. That can essentially help the users browse or navigate to the content that they may be more interested in. There's also a number of other ways in search, oftentimes being able to bring in somebody's social network into the relevancy of the results. So tools like recommendations can often be used there, or recommendation tools. There's even movement, it's primarily academic at this point, but which is called learning to rank, which is actually trying to figure out what the search similarity scores are based on classification. You also often see machine learning when you want to try to personalize the search results. So, for instance, if you log into Google or Bing or any of those, they try to use your past history, your user profile, all of that. They feed that into machine learning techniques to build models about what kind of results you would be interested in. And then they use that at runtime when you do searches to tailor results to you. So yeah, quite a bit of applications. And then of course, at the lower level of actually parsing and looking at the language, being able to do things like identify the parts of speech in the content, being able to identify phrases, being able to identify more semantic relationships in the content. Those are often also solved using machine learning approaches.
That is very interesting. What I'm thinking is, if I was a clothing retailer, I know that every SKU, this is a shirt, this is pants, these are shoes, and I don't need somebody else. I don't need a tool to classify my garments into what type of garment they are. But if you're pulling in documents, articles, things that come off the internet, this approach fills in that information that you already have about a physical project, a physical product, with machine classifications or machine learning attributes that help improve the search results.
Yeah, and actually, even on the product example, I mean, imagine, if you will, that you're an aggregator of products from a lot of different manufacturers. Oftentimes that data is noisy or it's incomplete, et cetera. Machine learning can kind of help fill in the gaps. But make no mistake, this stuff isn't perfect either. This is something that evolves over time. One of the principles of this is that you have to feed back into the system to help correct it when it's wrong. And in many cases, you can be on par with what humans are able to do. In other cases, humans may simply be better at it, but of course they don't scale as well in terms of dealing with large amounts of content, right? And so it's always kind of this back and forth. The most successful systems I've seen, there still is some human in the loop, if you will, that is helping guide the system or giving feedback as to how to improve the results. But as you get more and more data, you can often take advantage of those kind of implicit suggestions by the fact that users click on something or they don't click on something, and then you can use that as feedback too.
The question of how the inline user improves the results, I think that's very important. I'm going to come back to that when we talk about some specific machine learning algorithms. I want to wrap up a little bit on the Mahout project overview. What language is it written in?
I'd have to check. I mean, I'd say the large majority of it is Java. I'm trying to think if we have anything else in there. I mean, Hadoop is Java-based. I think so. We're primarily a Java project. I know some people have contributed Apache pig scripts. So if you qualify that as an actual programming language, then maybe you could say that. There might be some Python or other things sprinkled in, or Bash scripts sprinkled in as utilities around using Mahout, but the large majority of the code and the algorithms are Java-based.
And how is the project structured?
In terms of people, or
how many people? Yeah, how many committers are there? how many, is there a community around it? How active is it?
Yeah, I think there's a pretty large community. Their number of committers is, I would say, I don't know, roughly 15. It's an open source project. It's, at Apache, most people are volunteers. So, uh, you know, things come and go in terms of people contributing and what they want, what their interest level is, et cetera, which is kind of the open source way. We are working towards our 1.0 release. We just had what we call point 8. So right now we're primarily focused on uh, cleaning up the APIs, cleaning up the documentation, making sure that this is something, once we hit 1.0, that these are the APIs we want to support in a backwards compatible way. We do take in some new algorithms now, but we're primarily focused on the ones that we have already and making sure that they work well. And so that's the primary focus.
Great. Well, that kind of wraps up the general Mahout questions I have for you. I want to talk now a little bit about each of the 3 C's you mentioned: recommendation, clustering, and classification. I guess that recommendation is a C if you call it collaborative filtering.
Yeah.
So let's start with recommendation. We've been talking about it, but let's reset with this question. What is recommendation?
So the goal here is that you're of collaborative filtering. So I guess you could say there's typically 2 kinds of recommendations. One being, which is not in Mahout, being content-based recommendations, which is taking information about the user and/or the items that you want to recommend and try to understand at some deeper level what is intrinsic about those things so that you could recommend them to the user. Collaborative filtering, on the other hand, is simply just using the votes of users and/or actors in the system to then, group all of that together and make try to understand which neighborhood some new user fits in, and then make recommendations based that way. So it's collaborative filtering is more of just simply a voting mechanism. So, if everybody is buying some particular book and you're similar to those people, then we should recommend that book to you based on the fact that there is a large number of votes for that item, right? Even that, whereas a content-based one would try to say, oh, well, this person likes to read computer books and this is a computer book, and so on and so forth.
The intuition behind it is, Grant, we're going to try to find users like you. Then we're going to recommend to you some of the more popular items that users like you that you have not seen or bought or read yet.
Yeah, and so that's one of the 2 approaches under collaborative filtering. That typically would be called user-based similarity or user-based recommendations, which is we're going to find users like you, and then we're going to find what items they've bought or looked at or whatever, and then make recommendations off of those. The other approach is called item-based similarity, and typically it's just kind of flipping the question around a little bit. It's taking items you've bought and then trying to figure out what items are similar to those items based on what other people have bought. So it's slightly different, I guess, when it comes to the math, but it hopefully returns similar results or better results in some cases. So, and then there are a few other approaches around collaborative filtering too, but those are the 2 main ones.
When you're talking about this step where we try to find the users that are like you, what is the concept of likeness that one of these algorithms would use?
Yeah, that's a good question. I mean, so in Mahout in particular, this is a pluggable concept, generally we use this notion of similarity or of distance because in many situations with these algorithms, what you're looking at, and this actually goes back to our search interview, you're looking at some n-dimensional vector space, and you're essentially asking what is the distance between these 2 vectors. And so there's a number of different ways to calculate distance, and so in Mahout that will be That's all pluggable, and you can, we ship with a number of different distance measures, but you can also plug in your own. So you could use, for instance, the classic Euclidean distance, i.e., how the crow flies, if you will. You can use the taxi cab distance. You can also use things like cosine, similarity, and a bunch of other ones. So it's a very pluggable notion, and what people typically do is test based on their data and the properties of their data. They'll choose an appropriate distance and then test to see that it produces reasonable results.
The vector then is the set of items that you have already read or bought or done something with?
Yeah, typically.
It's not the data about yourself, like your age and your address and your things like attributes that they might know about you.
Well, it's in the collaborative filtering sense. It's usually just counts, for instance, of all the votes for a particular item, right? And then you essentially get this large matrix out of it that you're doing these distance calculations where you're comparing your particular user's purchase habits or whatever with that larger matrix to see which ones overlap.
You said the similarity function is pluggable, and I would guess there are going to be other ways to tune these algorithms. If I have a bunch of data, I've run some recommendations on it, how do I know when I'm done, or how do I evaluate the quality of the results that the algorithm produced?
Yeah, no, that's a great question because one, you're never done, but at the same time, we all have to ship our code and put it into production. So we do provide in Mahout, for instance, some tools for trying to evaluate the quality of your data. What often is done in this situation is you have some amount of data already that's obviously feeding into the system, and so you have past answers that you've given, and so what you can do is withhold some of that data out of the training of the system, and then just simply run that data through and see what kind of results you get. So it's kind of a hold out some amount and then process. Many people will have user groups or focus groups that they'll ask people to evaluate the system, or they have their own quality assurance team or relevance team in house. Other people will do A/B testing where they put this data up online, and some percentage of users get the new recommendations, and some percent don't get any recommendations or get the old recommendations. And so then you could look at whatever metrics you track as an organization to see whether you're doing better or not. In many, at least in e-commerce, it's often, are people buying more things or not? Are they actually clicking on the recommendations and then buying those items or not? So there's really a variety of ways you can try to figure out whether you're being effective or not.
If I'm writing a conventional program, generally there's a clear idea of what it's supposed to do, and I can write a test case, say it does what it's supposed to do. What I think you're saying here is in a recommendation, especially in an e-commerce setting, that the definition of a good result is really market driven, and that depends on user behaviors when presented with the new recommendations, which inherently is not possible to totally predict, because if you could totally predict user behavior, you would do that instead of using Mahout.
Yeah, no, it's in many ways like search. I mean, anytime you're dealing with these kind of fuzzy problems, you have a couple different levels of testing. Obviously, you've got to make sure that the system, functions and works just like any other program. But so just like any, like in any program, you obviously have your functional testing and all that to make sure everything's working at a system level. But then in these kind of problems where there's this notion of where it's a bit fuzzy or where there's this subjective experience, there really isn't necessarily a perfect way to get at the whether this is working exactly right or not. And like you said, if you knew the answer ahead of time, well, then you would just do that. And so what you typically see are approaches where, again, you're doing like the A/B testing, or you're tracking what some user groups do, or early beta testers, etc. And so when you can of course capture all of that information and then feed that back into your internal testing. But keeping in mind that as you improve the system over time, those results may change, and so that you may need to go and update your tests again in the future. So yeah, it does require some bit of higher level thinking around testing, but you typically know it when you see it, and you can tell when the system's being effective that way. And then in particular, there's often ways you can measure it via things like whether people are purchasing more, or they're reporting that they have better results, and so on.
It sounds like a great opportunity to roll out a couple different algorithms to small slices of your user base and evaluate how they perform in the real world before you roll it out to your entire user base.
Yeah, no, that's exactly it. That's this notion of A/B testing. What I think you're starting to see more and more movement in this space is that you're always experimenting. There is no one answer that you ever definitively say is the final answer, and we're just going to leave that deployed for the next 6 months or until the next major product release. I think people who design these kinds of systems, one of the best pieces of advice around it is just simply, you have to build experimentation into it from day one. This cannot be something you go and think about doing after it's up and running, because by definition you're dealing with subjective answers, and so if you're not delivering quality results to your users, then your system is going to fail, no matter how well it scales or no matter how well it's engineered.
Sure. Okay, well, we've been talking about collaborative filtering, and some of these discussions I'm sure are relevant to other algorithms. Let's move on and talk a little bit about clustering. What is clustering, Grant?
Sure. So clustering is typically an unsupervised learning task where you're trying to automatically group together similar items. So finding users who are alike, or who documents are alike. People who are perhaps Google News readers, they can see clustering in their everyday lives. And that when you go to the Google News page, there will often be some lead article that they have. And then there's usually a link just underneath that article that says, see all 5,000 other results like this one. And so what Google is doing underneath the hood there is an example of time-based clustering. They're taking all of the content, they cluster it into these groups, and then they're identifying some particular article out of that cluster that they think is representative of that content, and presenting it out to you as the user. And the nice thing about that for us users is, we don't have the time to read all 5,000 of those results, and so we can just focus in on that one and then go read the next representative article about some other thing. I would say that's a good example of clustering, and that people may be familiar with just in their day-to-day lives.
Now, Grant, if I had 5 predetermined groups and I said I want an algorithm to sort all these incoming news articles into these 5 groups, that is not clustering, correct?
No, that's typically a classification problem. If you know those groups ahead of time and you have labels for them, that's typically a classification. That being said, I mean, you could treat new content coming in, and you could essentially ask the question, which cluster is it close to? And in fact, what people often do in these clustering systems where they have new content coming in all of the time, they run their clustering algorithm, they produce their original sets of clusters, and then they say they may not run it again for, let's say, another day, right? But the news is, of course, still coming in. And so all of that new content that comes in the meantime, they may just say, okay, which cluster is this closest to? Add it to that group. And so you're not changing the clusters in that time period, but then the next time you run, the clusters may be different because that new content reshaped the similarity metrics of the system.
That sounds like a great strategy for combining clustering and classification to solve a real-world problem.
Yeah, in fact, like in Mahout, we have classification algorithms that simply sit on top of our clustering algorithms, and right. So you're essentially saying, I know these clusters are the buckets that I'm interested in. Let's use them for classification, and you're essentially adding content into them. And underneath the hood, the math for solving these two problems, and actually all three of these problems, is fairly similar. So it all starts to look the same algorithmically after a while, even though you may be approaching them in different ways from the kind of problems you're trying to solve.
Sure. But what I was getting at a couple of questions back is the clustering, the algorithm is looking for inherent affinity groupings within the data,
Yep.
not predetermined, correct?
Right. You don't have any idea up front of what the groups are. Typically in clustering, you say, I know I want, say, 10 clusters, but you have no idea what the labels are for any of those clusters. Now, you may try to determine that after you've done the clustering, but you typically don't know what those labels are up front.
Are any of the clustering algorithms good at, after you've clustered everything, saying, oh, this cluster is Apple news, and this cluster is weather news, and so on?
So are they good at identifying what the labels are?
Yeah, what is the meaning or description of this cluster in a way that's useful to humans?
I mean, so typically that's kind of a post-processing algorithm. Like in Mahout, we have tools that will go through the clusters and find the most common words or phrases in those clusters if you're doing text-based stuff. What clustering often produces is some notion of a centroid. What's the center of the cluster? And so sometimes what people will do is pick whichever document or item is closest to the center as the representative item of that group, or they'll go and sample some set of the items in that cluster and then use those to show to the user. But typically, actually identifying the labels is a post-processing technique, because once you have the cluster, it's all right, go through and figure out what are the key features of that cluster.
Grant, could you choose a popular clustering algorithm and describe at least intuition behind how it works?
You put me on the spot here. So probably the one most people start off with in clustering, it's kind of the good one to get started with. It definitely has some shortcomings, but is k-means. The k in k-means means the number of clusters you want. And so up front, the user picks the k, it says I want 10 clusters. And then what the algorithm does is chunk through all of the data, and so first off, it starts with some sample. It tries to pick 10 example centroids or 10 example centers of clusters, and it may either do that randomly, or you may seed it with what you think are good centroids to begin with. It then goes and runs through all of the data and calculates the distance of every point to the centers, and then to that list of centroids, so i.e. the 10 centers. And it then puts that item into the cluster that it's closest, of the centroid it's closest to. If that makes sense, right? And then it's an iterative algorithm. So after it's done with that, it'll then go and update the centroids because perhaps it's moved based on the fact that you have this new content, these new items in the cluster, and then it essentially repeats. And it keeps doing that until the center or the centroid has not changed in a significant way since the previous run. So this is an iterative algorithm, and in fact, it isn't necessarily guaranteed to converge. And so what you typically do is you limit the number of iterations it can do, or you give a convergence threshold that says, if the centroids haven't changed by a certain amount, then stop.
So is clustering, we've been talking about clustering articles. Is clustering typically something you do to text, or can you cluster anything if you have a distance metric?
Yeah, you can cluster most anything. Like I think I mentioned earlier, the power example or the manufacturing example. People often do clustering by looking at over time how a particular machine or item is operating, and then you're trying to, instead of, it's interesting there, it's almost the reverse, is you're clustering everything that's operating normal tends to cluster together, and then you're less interested in the actual cluster, but you're more interested in the outliers, right? The things that don't belong to any cluster or are at the very fringe of a cluster, right? Because those typically represent some event that you're interested in, right? And so,
Sure.
you can also cluster people. I mean, clustering is another way of doing recommendations. Put together all the people who have bought similar things and then see what, which items one person bought that the other didn't. So you can do that off of clustering as well.
And clustering text, how do you evaluate a distance metric between two text documents?
So it's actually similar to search here. I mean, what most people do is a vector space distance measure using like cosine similarity. So if you have two documents, they each create a vector in an n-dimensional space. If you bring the tails of those two vectors together, that creates an angle. If you take the cosine of that angle, that's usually a pretty good idea of similarity, because the cosine of the angle 0 is 1, and and then it's goes between -1 and 1. So if they're totally pointing in the opposite direction, that would be a -1, and then everything in between, right?
And we were talking about recommendations. Ultimately, the test, if you're in an e-commerce setting, is market-based. How do you evaluate when your clustering algorithm has done a good job, or two different versions of clustering, which one is doing a better job?
Yeah, that's actually a tough question, and this is an area definitely of ongoing research, and it's also an area where I personally have never felt satisfied by the ability to do it. It's, to some extent, it's you know it when you see it. When the clusters look right just based on your own intuition of looking at them. So that's kind of the smell test, if you will. Does this smell right? Does it look right? There's also some metrics that people have created over time that do things like look at what are the distances of items within the cluster, and then what are the distances between the centroids of clusters. And those can be useful metrics as well. So, ideally speaking, you want your clusters to be tight together, very close together, and then the distance between clusters is significant enough that we as users can delineate between the clusters easily. But in practice, that's often not the case. So it does become much harder. Mostly I look at clustering as a way to help users browse and or navigate through content, and not so much as a way to produce some final answer.
Well, let's move on to classification, the third of the 3 C's. What is classification?
So classification is essentially you're trying to answer some question like, should I show this user this item or not? Or is this piece of email spam or not? Typically, if you're doing binary classification, it's an either or question. Or you could also do multi-label classification where you have some set of labels and you're trying to pick the one that best represents that piece of content according to your training model. And so it's a supervised learning task. You typically have some people who do some upfront work to produce training data, and then you learn a model from that training data, and then you test that model and then put it into production once you're satisfied with the results.
Unlike the other two, it sounds to me like it's going to be easier to evaluate a classifier than clustering a recommendation because you know the answer.
Yeah, you typically know the answer, so it is easier to evaluate. You typically have some, say you have 100 items, you would maybe use 90 of those items as training data, and then you would keep out 10 of them to use as test data. Now, of course, 100 is just an example. You typically have a lot more than that. But while it tends to be more accurate that way, you still, of course, have you take two people, put them in a room, and ask them to apply labels, and they won't necessarily agree either. So you still have room for error here, and or room for people to say no, it should be this instead of that.
There would also be the question of whether false positives or false negatives are considered more costly for whatever purpose you plan to use it for?
Yep, definitely the case. So, in the medical domain, there's obviously pretty high penalties for being wrong. So you tend to want a system that's more cautious. Whereas, if you show somebody the wrong ad every now and then, that's not necessarily a big deal, right? And so you definitely usually have some sort of cost function associated with what you're doing, and you also need to take that into account as you build out the system.
What kind of size of data set do you need to do a decent job training a classifier?
Yeah, that's one of the good internal questions. It depends on the algorithm, but usually you're talking at least hundreds or thousands of items per label. And so you want to make sure you have and then of course you need both positive and negative examples of that one. And so, you're typically talking thousands, or hundreds or thousands, but, in the really large scale systems, you have millions and millions of them just because every time a user clicks or doesn't click, that's an answer as to whether this is, whether you classified it correctly or not, right? So in many systems, especially large user-facing systems, you have a lot more negative data than you have positive data. And so with some algorithms, you also need to make sure you balance that out and so that it can make appropriate decisions about how to weight accordingly.
Can you take us under the hood for a classification algorithm?
Sure. So kind of everybody's favorite classification is called naive Bayes. And essentially what naive Bayes is doing underneath the hood is looking at, so if you're doing this across text, it's essentially looking at what are all of how many times do particular words occur with a specific label, and it keeps track of that across all of the examples it's seen, and then uses those as weights in the model, such that when some new content comes in, you're looking at those weights and comparing. You're looking at the item you're trying to classify. You look at what words it has, and then you look at what those weights are, and you produce an answer as to what the probability of that document being classified with that label is. And then you essentially output your list of your guesses, if you will, or the probabilities of those labels. For people who want to get started in this, it's a pretty easy one to implement. I guess if I had to recommend a book, there's a great book on a lot of these things called Programming Collective Intelligence, which actually explains the algorithms and shows code on how to do these at a pretty simple level. Of course, you can go and take that from there. Mahout in Action also covers a lot of these things in detail too.
Great. Well, Grant, if our listeners would like to follow you and your thoughts, how can they do that?
Sure. Let's see. I tend to blog at my company's website. So lucidworks.com is my company. I tend to blog there from time to time. Also, my personal blog is grantingersoll.com. And then on Twitter, I am GS, INGERS, G Singers, if you will. Those are probably, I guess, the main three ways. And speaking from time to time in various places. And I think, as you mentioned at the top of the show, I do have a book coming out called Taming Text, which is essentially geared towards being an engineer's introduction to natural language processing, search, and machine learning using open source tools. So what me and my fellow authors do in there is take these common things like classification, clustering, search, etc., explain the basic principles behind them, and then show examples of how to solve those problems using commonly used open source tools like Solr and Lucene, like Mahout, like OpenNLP, etc.
When will that book be out?
So we're in the final stages of editing and layout right now. I don't know the exact date, but I'm guessing it'll probably be towards the beginning of early January, but maybe in December as well. I'm not entirely certain as to what happens in the process at the moment. After layout's done, I don't know how long it takes to publish.
If listeners would like to learn more about the Mahout project or maybe get involved, what's the best way for them to do that?
Mahout.apache.org is the main URL for Mahout. On there'll be a number of links to our wiki page, which has tools on how to contribute. Also has a lot of references to books and articles on Mahout and machine learning. There's also the mailing lists, which are described on the main web page as well. It's a great place to just simply come ask questions about machine learning, regardless of whether you use Mahout or not. The people and practitioners there are typically pretty good about helping guide people to appropriate resources, whether that's within our community or is better served somewhere else.
And if listeners would like to find out about Lucid Imagination, what's the best way to do that?
Yeah, so actually, we just recently changed our name from Lucid Imagination to LucidWorks. So lucidworks.com is our new website, although lucidimagination.com will redirect you there. And on there, we've got a variety of resources. People can also reach out to me, Grant at lucidworks.com, and I'd be happy to try to direct them in the right way too.
Grant, thank you very much for speaking to Software Engineering Radio.
Thank you. I'm glad to be here.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more information about the podcast, including other episodes, visit our website at se-radio.net. To support us, you can advertise SE Radio by clicking the Dig, Reddit, Delicious, or Slashdot buttons on the site, or by talking about us on Facebook, Twitter, or your own blog. If you have feedback specific to an episode, please use the commenting feature on the site so that other listeners can respond to your comments as well. This and all other episodes of SE Radio is licensed under the Creative Commons 2.5 license. Please see the website for details. Thanks again for your support.